Well, we have question 4 here that says in the diagram below, the circle centered at M, which is the center of the circle is like M, which is 24, M24, the center, like the circle, and it passes through the points C, -1, 2, and it cuts the y-axis by E there, and then the diameter CMD, that the diameter CMD is drawn, and ACB is tangent, ACB tangents of the circles there. Okay. In the previous question, we work out question 4.1.1 for question 4.1.2. We already find the value of D here. It was 5 and 6. Now, in this question, we are asked to calculate or to determine the equation of AB in the form y equal to mx plus c. AB is this line, is the tangent of the circle. Now, this is what we're going to find. To calculate now, let's split the board and then move. I am going to write here 4.1, 4.1.3. So we are asked to calculate the equation of the tangents. The equation of the line AB is what we're looking for. So we do know that the equation of the line is given by y equal to mx plus c. So let's first pass the same graph that we had there. Paste it here. Okay, this is the graph. Now you know that it's a straight line, so it is given by y equal to mx plus c. So this line. But now when I look at, we only have a line and it points one point here. How can we determine the equation of the line then? Okay. If you look carefully, we have tangents, the tangent line is there, and then also we have the radius of the circle, they all meet over here. There's a property that says that the gradient, okay, the property says this tangent to the line is always perpendicular to the radius. Okay, so what that means, by that I mean that the gradient of the tangent line will be equal to 1 over negative 1 over the gradient of the radius to the circle. Okay, the radius of the circle, or sometimes people write this the gradient of the tangent line times the gradient of the radius equal to -1. You can use either of them. Still gonna lead to the right answer. Now, because actually this is what we know from the equation, we know that AB here, the line AB is perpendicular to CM. Okay, the reason why we write this. Now, let's first work out MR, the gradient of the tension of the radius. MR will be given by, okay, the gradient itself is given by, M is given by the change of Y over the change of X. Say Y2 minus Y1 over X2 minus X1. Now, therefore, MR here will be equal to, that's not, we're going to use 4 minus 2 all over 2 minus 1, so 2 plus 1, and this is equal to 2 over 3. Now that's MR is 2 over 3. Now that we know MR, we can also find MT. Okay, we can use that formula, but the quickest way to solve that is by reversing the order of the fraction. Okay, switch the denominator with the numerator. So 2 over 3 will be switched, and this will be 3 over 2. This is MT. Now that we know the gradients of the straight line, we can substitute it okay, this gradients into the equation of the straight line, and this will be, we can say therefore, y will equal to 3/2x plus c. Now we can sub them a point in the straight line. The point is also the point c. It's just this c and that c are not the same thing. Just by coincidence, they're all c. Okay, but we're gonna sub the point in the straight line. So the point that we have the straight line here is the point c. So to find c. So here we use c to find c. You see. So I'm gonna sub here. I'm gonna sub 2 for y, because here this is the x coordinate, the y coordinate. So I sub 2 for y, and then -1 for x. Okay, this will be 2 equal to 3/2 times x, which is -1 plus c, and then that makes 2 equal to -3/2 plus c. And then if I move the 2/3 over, so this will be 2 plus 3/2 equal to c. Then we can work out 2 plus 3/2 is equal to 5/2. 5/2, c is equal to 5/2. Now, then we can calculate, then we can find the equation of AB, the line AB. Therefore, the line AB will be expressed by y equal to the gradient m, which is 3/2, 3/2 x, okay, plus c, and then c is 5/2 plus 5/2. There we go. Thank you. Well, we have a question here. The question says, the diagram below, the circle centered at m equal m, which is 2, 4. M is the center of the circle, and then passes through the points C. C is -1, 2, and cuts the y-axis by E over here, and the diameter CMD, that the diameter is drawn, and ACB is tangent to the circle. Now, the previous question video, we did question 4.1.1, 4.1.2, and now we're going to do 4.1.3. All right, the question says, determine the equation of AB in the form y equal to mx plus c. Okay, this is the line we're looking for, AB. AB is the same thing as ACB, okay? We need to find this equation in the form y equal to mx plus c. Now, you can see we only know one point here, the point C, but we don't know nothing else about this line yet by looking at this. But we see that this line, and we also have a circle here. What we do know is that the tangent line is perpendicular to the radius of the circle. So I'm gonna write the question over here. Okay, this is the same graph, and I'm gonna write the question. It's question 4.1.3. We're looking for the line AB. Okay, and what we do know that the tangent line, so AB is perpendicular to the radius. So AB is perpendicular to CM. Okay, now two graphs are perpendicular if MAB is equal to -1 over MCM. Okay, or sometimes they write MAB times by MCM. I write it like this: MCM equal to -1. So we can use either any one of these to lead us to the correct answer. Now let's work it out. Okay, first of all, this is the line AB is a straight line, okay, and it is given by the form y equal to mx plus c. So we need to find this. So what can we do then? We say we can find the radius, the gradients. Let's first work out the gradients of CM, the radius. So this will be MCM will be equal to, let me first write the formula here. The gradients also is given by, M itself is given by y2 minus y1 over x2 minus x1. So MCM will be 4 minus 2 over 2 minus 1. That means, okay, I use this 4 minus 2 and then over 2 minus 1. So this makes 2 over 3. That's, so therefore we can say the gradient of CM equal to 2 over 3. Now we can use the formula to find out the gradient of the tangent line then. But we don't really need to do the formula, but what we can do, I call it in my English, okay, I call it the opposite of the inverse. What does it mean? What do I mean by that? I mean, if I need to find out MAB, the quickest way I can do, I will first reverse the fraction and then change the sign. So I will say what 3 over 2 and then change the sign. It was positive over here, and I make it negative, and then I reverse the fraction. Okay, this is the equivalence of doing -1 over MCM. So now we find the gradient of the tangent line. Okay, we're going to use this one, okay, to work out then the tangent line itself. So the tangent is given by y equal to m, which is the gradient, so plus c. Okay, m is equal to now -3 over 2. Then you can see this is the form of this equation of this line. Okay, and now we can sub in a point. The points here we can see, we can use the point C to find the value of C. Okay, note that this C is not the same as this C. They are different. Okay, just by coincidence that we have the letter C here and letter C there. So you see, now I want to sub in the coordinate of C. They are like -1 for the x, and then 2 for y. So I'm going to sub 2 for y. Sub 2 for y, and then -1 for x. So this will be 2 will be equal to -3 over 2 times 1 plus c, and that makes 2 equal to +3 over 2 plus c. Now I can just move the negative, the 3 over 2 over the equal sign. That will be -3 over 2 equal to c. And now 2 minus 3 over 2 is equal to 1/2. And then we find c also. And then we can find the equation of the tangent line will be given by -3 over 2. Okay, that's the m, the gradient, x plus 1/2. Thank you.